In our previous video, we talked about average rate of change for functions, not just functions related to movement, but just any kind of function. And if you remember when we did the average speed discussion, we went from a discussion of calculating average speeds to trying to figure out the speed at a particular value of time. And now we're going to try to do the same thing here, which is we discussed the average rate of change, which we said is the slope of the secant line here. Well, let's move from slope of the secant line to trying to figure out not just slope of the secant line, but slope of the curve itself. So if I were to pick this point here, let me just call this x naught here. And I were to pick another point up here. Let me call this x1. We could use the previous, work here to figure out the slope of the secant line between those 2 points here. And, that gives us the average rate of change of our function between x0 and x1. But we could say, well, what happens if we make the interval smaller? What happens if we make the interval smaller? So, okay, let me say here x2 is this point here. And so we can figure out what's the slope of the secant line from x0 to x2. And we could say, okay, well, what happens if we want a better approximation to things? Well, let's make the interval smaller. x3. So, there is, we can draw the secant line from x0 to x3 here. Well, we can make it even smaller. I'm running out of colors here. Let me steal another color. Go for some x4 point. And the idea here is that at the end of the day, we are coming up with some kind of line that is tangent. Line that is tangent to y is equal to f of x. If this got a little bit messy here, because there are too many lines drawn on here, the idea is at this point here, let me draw this point right on. There's one line that is just going to be tangent. And it's just going to kind of brush against that curve. And it's going to be tangent. And as we take x1, x2, x3, x4 closer and closer and closer to x0, x0, we're going to get better and better and better approximations to this tangent line. Okay, so this gives you an idea of, what are we talking about here with tangent lines? Well, let's go ahead and try to work out an example of this in a particular point here. Let's find the slope of the tangent line to y is equal to x squared at the point 2, 4. Okay, so how do we do this? So how do we proceed here? We want to find the slope of the secant line to the curve using x0 is equal to 2 and x1 is equal to 2 plus h. So, where h is something that is going to be a little bit bigger than 0, so 2 plus h is a little bit bigger than 2. Well, using our formula right here, delta y over delta x, change in y over change in x. So it's going to be f of x2, so that's going to be 2 plus h quantity squared minus f of x1, 2 squared divided by 2 plus h minus 2. Expanding out this term here gives us 4 plus 4h plus h squared minus 4 over, this simplifies down to just h. And what cancels here? Those 4's cancel. And just as in our average speed going to speed example, the leftover terms here have an h in them. The leftover terms have an h in them. And so we can factor out an h, cancel out h from the top and the bottom, and we're just left with 4 plus h. Well, our slope here is going to be, from x naught is equal to 2 to x1 is 2 plus h is going to be 4 plus h. Well, as x1 gets close to x naught, h goes to 0, and the slope, if h gets close to 0, the slope gets close to 4. And so we want to be able to say, we are doing a derivative calculation without you actually formally doing that. But we want to be able to say that the slope of the tangent line at the point 2, 4 for y is equal to x squared is 4. So if I draw axes here, here is our function, here is the point 2, 4, and so this tangent line has slope 4. In fact, we could very easily write down that, using point slope 4, y minus the y value, y minus 4 is equal to 4 times x minus the x value. So this is the equation of that line. Okay, so this idea here, this is giving us, this gives us the notion of the instantaneous rate of change. So what is the, before we had the average rate of change is defined in this way. What is the instantaneous rate of change? Here, the instantaneous rate of change for y is equal to x squared at x is equal to 2 is 4. When we hit chapter 3 and start doing derivatives, the derivative of this function at 2 is equal to 4. This is the intro to everything. We just have to build up how to do things rigorously to get there. So yeah, introduction to slopes of tangent lines and instantaneous rates of change.